Well, hello, everyone. Welcome back to the podcast. Ryan, once again, joined by my awesome co-host, Henry. Hello, Henry. Henry, you were green
Hi all.
earlier. I was going to say you're really holding on to that Morehouse coloring scheme.
No,
But
I need to replace my camera.
but the fantastic guests keep on rolling this season. And today we're joined by Georgia Harris. Many of us that have been in the industry for a long time have been on her mailing list for a long time. I know I was on that mailing list. Welcome to the podcast, Georgia.
Thank you.
We always like to start things off with, how did you even find yourself in metrology? It's a pretty common theme amongst our guests and ourselves. Like Henry, I think you were just pretty much born into it. But
Pretty
like
much.
for myself, I went into the military knowing nothing about it and then ended up getting into it. How did you find yourself into metrology?
So I started out in biology and chemistry and applied for a number of jobs in measurement laboratories. They weren't really measurement laboratories. They were analytical chemistry jobs or jobs at the university to use the chemistry and biology. And what I found was that I was making more money flipping eggs at Denny's. And so what I started looking around at some other jobs, and one of the last classes I took my senior year was physics. So I had not taken physics yet. And I enjoyed the laboratory aspect of the physics so much and gave the instructor feedback on all of their labs that they had the students doing. And then I saw a job listed with the state of Minnesota, and it looked just like what we had done in the physics lab. And so I applied for it. And the chemistry background is part of what got me in the door, because we were doing petroleum quality as well as metrology there. And after I interviewed, a couple of things happened during the interview. Is that there were four guys across the table, and there was a big window behind them, and the light was shining in my eyes, and I really felt like I was on the spot. And one of the things that they did was walk around the laboratory and hand me a weight and say, here's what a kilogram feels like. And I'm like, are you supposed to be touching that? And so they kind of got a kick out of that. But what ended up happening, and I guess this is what made the difference, is they went to HR. And I heard about this from one of the other supervisors who was not involved in hiring. He said they went to the HR manager and said, we have 4 people that we think are equally qualified for the job. How are we going to make this decision? And so they said, tell me about the people. And there was 3 guys and 1 woman. And they said, hire the woman. And so I guess that choice made all the difference. And maybe, now not everybody would agree with that approach, but that's how it got me in the door in metrology. So that was with the state of Minnesota. And from there, I was recruited by someone who ended up being my boss for a few years at NIST. And so then I moved from Minnesota to Maryland to work at NIST for the rest of my career.
Wow. What a jump, huh?
I've known Georgia for a long time. It's just education, outreach, passion for teaching, offering. Just if you were fortunate enough to be able to attend Georgia's training, still do this training online, right, Georgia, through NIST Weights and Measures?
I was up until last year.
Okay.
So after I retired in 2019, I worked part-time for another 4 years doing part-time instruction online, but I also went to some of the regional meetings last year and wrapped that up in June of last year. Now I still go and visit the laboratories. And so I have visited a number of laboratories over the last year, but I'm no longer officially doing training, but I still have a lot of people who contact me and ask questions and touch base, of course. So I periodically, will get a text message or an email or a Facebook message and say, hey, I've got a question for you. And I'll answer it, of course. maybe not that day if we're out hiking or if we're traveling that day, but typically I will get requests still for that.
So did you find that you got the teaching bug early? Like, did you start teaching fairly early, or when did you find out that you're a teacher?
So if I went back, I've thought about this more recently, is that one of my first jobs was when I was in high school, and my gymnastics coach asked me to help with the summer program. And so I was teaching little kids tumbling. And so as a leader or a teacher, what I found is that no matter what I have done, I've been involved with educating or leading in some way. So I've always been a teacher, I guess. And even when I was in Minnesota and I got involved with the NCSL at the time as a Twin City section coordinator and gave presentations there, it was on, teaching about control charts back in the early 80s. So
Nice.
there was, I've been teaching all along, but I would say that I grew as an instructor by looking at what the international standards were for education, and had some people that I would say were gifted as instructors who provided additional ideas and resources for that, and then just grew as an instructor all the way to getting our program at NIST accredited and encouraging management to maintain that accreditation over the years, and worked with A2LA even when they got their accreditation for their training program, and then tried to get NCSLI to follow through on the accreditation road as well, to raise the bar for a metrology education.
That was the ISET push. And what year was that, Georgia? Because that's the year I think I attended the trainer that you had done. And Ryan, this is kind of funny. So I'm attending the trainer that George was doing. Fantastic day, 8 hours. You used to be able to go to NCSLI if you were a presenter and take this class. They would provide it. They'd bring people in, and sometimes Georgia Dillip had done it. There was another woman, the name's escaping me, Georgia, that would come in. It was Jody or
Jovi Masters.
Jovi Masters would come in.
Yeah.
Yeah. Okay. Yeah. So it's just a
training clinic, right?
Yeah, and it was just a fantastic time. And every time you go there, you have your presentations. So Georgia's training. She's like, "Don't do this, don't do this," and I'm like, "Oh crap! All of my presentation has a bunch of that in it." So there, she's going like, "Oh, I'm going to teach tomorrow. I got to go home. I got to go that night and do all this work and remove all the animations and some of the stuff." And since then, and there's a lot of good content there that you do not realize that comes out of all this for metrologists and people that want to train. And I always took note of always have space percentage, the degree Celsius, degree Fahrenheit, the cases of KGF, LBF, all of the units. What are the other ones, George? I'm forgetting.
Well, the units and symbols were a pet peeve of mine and Elizabeth Gentry, who's now Elizabeth Benham, is that the NIST Special Publication 811 has the units and symbols in it and how they are supposed to be presented. And one of my favorite sayings was always, if we don't get it right as the metrology community, who else will? So I've reviewed engineering textbooks, engineering papers, and they drive me crazy. So when we were involved with the American Society for Engineering Education as outreach, I was on one of the committees for the measurement committee, and they would have me review papers. And so that was the number one thing that I reviewed on those papers, is the presentation of units and symbols have to be right. If you're in engineering or science or certainly metrology, right? Is that if we don't get it right, who will? And all you have to do is even look at some of the papers that are presented and look at the material on slides, even from big name companies who are not getting it right. And then the same thing holds true with their calibration certificates. If I look at a calibration certificate and on page 1, they have 20 degree symbol, capital C. The next page, they have 20 space degree symbol, capital C. The next page, they have 20 degree symbol, space, capital C. And they're all 3 done differently. They're all inconsistent. How can you have confidence in the numbers that go with those if they can't get the symbols right? And so that definitely was one of my pet peeves. Attention to detail is important with the teaching. And so if you're teaching somebody, you got to get it right also, right? Not just communicating the measurements, but the instructors need to get it right. But I just got feedback from someone. It wasn't made, he didn't name names, but he said he gave a presentation to his local support group. And he said his evaluation would have been that he didn't make enough eye contact, right? And so I said, well, probably that evaluation card also had, oh, you were very brave for getting up and speaking. Your dynamics and energy level were great. And you also used emotion and story to communicate a great message. And he goes, yeah, you're probably right. But what do we focus on is the negative, right? Mm-hmm. And so anytime I would give feedback to other instructors, I would make sure that I used what I called a 3x3 or a 5x5 card. So I would give feedback and make sure that we had 3 positives. If I was going to have 3 negatives, I at least had to have 3 positives, but it's better if we do 3x1 or 5x1 so that you can focus on what's the one thing that would make the most difference if I improved this. And that way you're encouraging people at the same time. So people want to improve, but they also need encouragement and support.
Absolutely.
And some don't know until somebody's brutally honest with them.
Right.
This is our field is generally difficult because people, at some levels, Georgia, right? Because you have to get up and present. And when you get up and present, no one ever knows how you're feeling. I presented with COVID. That was a horrible time. Like, I had 5 days with a mask on and cough. That was one of the worst ones. And I was told, yeah, come down. People really want you to present. And as a presenter, you always have these difficult situations, or you may wake up, you're not feeling well, and you want to bring everything with you. I know the one class you sat in that I did, I had just had eye surgery and a bunch of floaters, and the bright lights were driving me nuts. Though these are the things like you want to engage people and do that. And as people, what I'm getting at is the people in the audience are just as important as the presenter at sometimes, right? Just to get that feedback and have them interacting with them and open for questions and being engaging and breaking that up. And now I've attended some of your training online and other training. And Ryan, I can tell you, Georgia is just absolutely fantastic with that. She hands pipe cleaners got handed out, I think, the one time for us. It's just knowing that people are audio, video, and kinesthetic learners, and not everybody fits in the same group and mush, that you have to, do that, and you have to break things up. So Georgia, you want to talk about some of that, because it's really the people that are out there presenting, we do get in a habit of, I'm just going to write just PowerPoint, and that's what you get left with.
Get at the meat of it.
So even with giving a presentation at a conference, my goal is, what do you want people to know and do with this? Am I just going to dump information for the sake of standing up here and talking, or do I want people to know and do something with this? If you're just standing up there talking, it's not really education. If they're not going to apply it, there's kind of no point. And so for me, education is all about application. And so if you're going to have a NIST researcher talk about their research, for example, the example is someone needs to replicate their research to to validate science, right?
Mhm.
And so that's part of what we do with science is it has to be repeatable. And so you don't want people to just sit there and listen. And so maybe somebody is given a presentation of here's how we did some volume calibrations. And I sat through a presentation in Mexico at St. Am one time, and they were doing volume calibrations and talking about all of the uncertainty components that they used. And I noticed that they used a couple of different uncertainty components than what we had used. And so we got to have that as being part of the Q&A, where the goal there was they shared that so that we could have that discussion and that feedback so that we all would benefit and grow from that, right? And so the other thing besides that for just presentations is the VAK, or the visual, auditory, and kinesthetic, is especially important in metrology. So I can sit and listen and have no idea what something might feel like, right? And so if I'm looking at a triple point of water, right? And you tip it over and you feel what that feels like. It's very different than reading about it or even just watching that being done. The kinesthetic aspect of that is so important. Or if I'm lifting up with forceps a kilogram, right? I have an idea of how much that kilogram weighs in my forceps. Or if I pick up a 1 gram weight, you have a different leverage support to your hand depending on what you're doing. And that kinesthetic piece of it you can't get from reading. Or you can watch somebody plugging in cables to a box to do electrical measurements, but how hard do you have to push to make sure that it's fully seated? Or a torque wrench, how far do you have to push to get 75 whatever units versus 50 whatever units? Our tires on our RV were last torqued to something like 475 foot-pounds. And it's like we went to a tire shop and I asked them if I could try the torque wrench that they used on there. It's like 8 or 10 feet long and it was heavy. So that kinesthetic piece of it is that I don't think you can get away from that in metrology. And so when you try to do things online, unless it's in a hybrid format or people have to go and apply, say, okay, we've covered this now, go in your lab and make these measurements.
Right.
Okay, we've covered this now, go in your lab and make these measurements. Until you have that piece of it, I think it's super difficult for people to get 100% learning out of it.
Absolutely.
And that gram weight, was that, did you have them weigh it without the calibration sticker on it and then with the calibration sticker on
it? Yeah, you want to hear about another one of my pet peeves, right?
Is it the K? I didn't bring up the K. When you look at the certificates, that's always now. I think I got this from Georgia. All Ks need to be italicized when you're talking about coverage factor, and lowercase and italicized. So now every time I see it in a presentation that it's not, I remember where it came from.
Is that a Kelvin? Is that a Kelvin? Yeah. So you're talking about Kelvins now.
But I love this discussion though, because Georgia, I encountered this exactly, right? Because I started the school wanting to help labs, and then you get 5 years into it, like I am, and you're working deeply with them, and there's disconnects between, hey, I'm teaching this, even if I have really good camera work, I have amazing setups behind me, great angles, and all that stuff. But without a facilitator, someone there with that person helping them or putting them through demonstrations, or like you're saying, the hands-on, like the first thing that came to mind when you were talking about it is pumps, right? Henry, if someone was doing one of those hand pumps for a Morehouse press, right? How hard do you have to put it on? How hard is it to do one of those, the little fine adjust,
not hard,
right?
Not hard at all at half capacity when you're at about 2,000 PSI, but really hard when you're at 4,000 PSI.
Exactly. And so we ran into the same thing. And I just finished development on a train the trainer course, and it makes sense now why those things come around, right? Because it's not an inherent, or maybe it is something, there's pieces of it, like we were talking about earlier, that maybe you are somewhat born to be a teacher. It's been a weird thing as I've gone along longer. I've been teaching for over 10 years now, and it's like there are some people that are just naturally better at conveying learning subjects, or maybe they remember better, or they're able to remember what it's like not to know things. Sometimes I see that's the problem with when I'm teaching middle management or lead technicians to be a trainer. It's hard for them to remember the things that they didn't remember back in those times. There's a lot of like, oh, they should know this. No, how would they know that? There's none of this stuff that anybody knows. They have to learn it.
There's so much. I went to a recent, and Georgia may know some of the, I went to a recent session and they were talking about how to make us better presenters. And one of the things they did, I have a pen here, it's quite sanitary. They said, put it in your mouth and bite on it, and then say these lines and do your presentation. And then they said, pull it out. And they were doing all these different things for different people. If you had an accent, there were tricks to get your accent going and everything else. And one of the major things was eye contact, stepping forward when you're presenting something, and then eye contact. If you really want people to be engaged, they always said, look at one eye and then shift to the other eye. And that was the first time I had ever heard that. I knew look at somebody in the eye contact, but they said, really, if you look at just one eye and then pull over, and that's hard to do as you're trying to recall. A lot of this takes a bit of practice, and it's very difficult to do as you're trying to remember everything that you want to convey and teach people.
Yeah.
Yeah, another example of the visual, auditory, and kinesthetic is I worked with an engineering student one time, and she was working on her master's degree in engineering and came to NIST for her last co-op activity and worked with us for about 6 months to finish up her degree. And in that particular engineering program, they had no laboratories whatsoever. It was all classroom and online. There was no laboratory. There was absolutely no kinesthetic. So when we went into the lab at NIST to make some measurements and to get her up to speed on the content we were teaching and wanted her to do, she had never done physical labor or physical work. And so one of the measurements that we do in weights and measures is be able to lift a 5-gallon test measure full of water. And so 5 gallons is, going to be 40 some pounds, 25 kilograms. You have to be able to lift that and empty it. So when you think about how they're testing gas pumps, that's the size of the measures that they use. I call them buckets with a gauge, but that's the size of those measures. You have to be able to lift them and empty them. And she had never done that kind of work in her life and had to have help lifting. And so you think about that aspect of how much she missed out on in that engineering program by not having any physical activities or even knowledge of that. By the time she got involved in measurements, it was, it blew her away to even think about having to make measurements with that knowledge.
This reminds me of, because we have the unfortunate situation here in our industry where we really don't have a lot of collegiate options, right?
Nope.
So in a lot of ways, our labs have to make up for that. And I go, much like you, Georgia, to a lot of different places. And it surprises me sometimes when they don't have training setups. They don't have things that, if I'm sending a bunch of people on site to do temperature readouts, like say Wattlows and stuff like that, I'd probably have quite a few of those type of Wattlows in my lab so that people can practice on it before they're sitting in someone's expensive facility pushing buttons and messing around, right?
You hope.
You would hope, right? And so similar to that, labs kind of have to pick up that slack and have areas and realistic training scenarios, because it doesn't, like you say, it doesn't matter how well we lay out that foundation of education if they can't go and actually practice it in a meaningful way.
Well, I would say that's a problem with schools too, or laboratories. So people said, "Oh, why don't you come to our lab and do the training?" And I was like, "I am not going to use your reference standards and equipment in your laboratory to do training and risk. You want to talk about risk with the latest, 17025, and what is the risk? You think about what it costs to calibrate or replace some of that equipment in the lab. You don't want to use that high-end equipment to train people from other labs, certainly, but even training your own people, you definitely want to keep an eye on that."
Training is so rough on equipment, and oh man, it doesn't matter how much I look over stuff. Like I remember back in the military, block one, we teach Viswar, like of all things, why would that be block one? But the connectors and stuff, you check them before class, and then by the mid class, you got 5 broken. You're like, how did this happen?
Right. Exactly.
It's people, the way they handle things. Yeah, there's a lot. I thought you were going to say, George, about on their site, because it's not your equipment, so you don't really know. You kind of still know the equipment, but they may not have all the stuff that you expect them to have, and that ties into now, George. You were responsible for what 150 state metrologists and industry metrologists. Was that does that number
so
sound?
we had about 110 120 metrologists with the state weights and measures that we were legally responsible for providing training and support to. But when we were conducting training at NIST, probably half of our students were not state weights and measures. So half of our students were from, let's say, the military. So the Navy, the Army, the Air Force, they and the Marines, they all sent their people to NIST for at least the mass seminars that we had there.
Wow.
And then the pharmaceutical companies, so you look at Abbott and Eli Lilly and those companies, they all sent their metrologists to us at NIST. So we had probably half of our students were not weights and measures. And so that was primarily in mass and fundamentals. When we looked at our volume class, that was mostly state weights and measures, because there's only a couple of labs that needed volume at the level that we would teach with the gravimetric volume calibrations and that kind of thing. There were a couple of companies like Rice Lake or Tromner, or couple of the military labs, but then also Seraphin, who makes the provers or the buckets with the gauges. Most of those, they would come to us for training as well. But there's not a lot of people who were doing volume like the pipette calibrations. So Artel had a training program for that, or Mettler. There was another company for a while that I think was bought out by Mettler that did some training on pipette calibrations. But George Rodriguez did a lot of training with the pipette calibrations and covered that niche, if you will. So most of the people we had were focused on mass at NIST. And so you look at the cost of that equipment and the damage to that equipment. If I were going to go to the States and work on their equipment with the standards, that was pretty standardized. Historically, if we went back to the 60s, when NBS first started doing training for the states, all of the standards and equipment that they had at that time was given to them by Congress. And so it was very uniform in that. So that was the 5th time that Congress had distributed standards to the state for uniformity in legal metrology for weights and measures to have consistency throughout the country.
Now, when you say that, just for everyone else, hated to interrupt you, but this is the state labs, right? Weights and measures. They are responsible for your gas, making sure commerce right? That people are not getting
right. That your grocery store scales are all correct, that the big vehicle truck scales are all correct. When the trucks are fined for weight violations, those scales and weights have all been tested. So they're not limited. The states are not limited by law to only doing weights and measures. So about half of their customers are industry. So when you look at Minnesota, when I was there, we did a lot of our calibrations for the service companies. And the service companies were authorized by state law to go in and work at the scales at the grocery stores or to put the gas pumps into service. And then the state would come around periodically and validate that. But the service companies were authorized by law to do that work as well. And so maybe they worked for weights and measures in that sense to put something into service. But let's say the company that worked on the scales at the grocery store also worked on the scales, let's say at Medtronic. And so Medtronic was not selling product over their scales. They're producing, Post-it notes and pacemakers and blood glucose monitors, right? So Medtronic was making other things, but a lot of their weights may have been checked by the state lab. So the states are not limited to weights and measures. So probably in general, about half of the customers, if you want to call them that, are really citizens of the state or other states who get calibrations done there. Because the infrastructure for mass is really expensive to make it profitable. And so you have very few companies who can put a mass lab in place and make money on it. And so that's why a lot of them will rely on the states because they have the tax base to maintain the infrastructure.
And that makes so much sense now because I see a lot of places that are they're just mass and weight houses, right? That's all they do. But then they have a huge client base for that. Somewhat, it makes sense. I think that must be what they're also somewhat subsidized there. That's really interesting.
Yeah, I don't know that any private lab is subsidized for government applications, but they are authorized by law to put devices into service for weights and measures.
Interesting. Yeah, that I can think of a couple off the top of my head here locally in Utah, but I won't share who they are.
So I was just in the new laboratory in Utah last week.
Oh,
and
cool.
They have a new laboratory in Salt Lake City. It's really nice and a real cool upgrade from what they had before. So they have a lot of opportunity for growth there as well. So that's one of the things that I was talking to them about is that in the state of Utah, in government, they are working on what they call stretch goals. And so we got a chance to talk about some of the stretch goals for expanding on their services in the laboratory now that they have a new laboratory. So they're kind of excited about that.
I reached out to you're talking about the weights and measure lab here,
right?
I'm curious if I have I don't remember their name off the top of my head, but I'm supposed to come visit there at some point in time because we also have some upcoming YouTube stuff trying to work on awareness of metrology. Same thing. It's always nice meeting people in person like you that or virtually in person, that it seems like we're kindred spirits because we're trying the exact same thing, right? Trying to get any headway in people being interested in being metrologists as a career, right? And it's just it's so hard. I don't know. It feels like to me, and this is purely my biased opinion, that because it's not in the college systems, there's not parents that are going to put money towards, hey, I want my kid to be a metrologist one day, like a doctor or whatever. There's just not an educational push for it. So it's harder to find people passionate about it. And of course, when we do find someone that's passionate about it, those are the people that we're, trying to get them all, involved in all the right committees and in the great groups and everything. And we try and take care of them, like, stay in metrology. You're doing great.
Right.
But am I off on that, or do you guys feel the same way, that it's not in a pipeline of any kind to give anybody even that idea to be a metrologist?
Georgia touched on it earlier with the female engineering student, right? And that's all a lot of engineering students. Some of them get work where they learn to machine things and they build a go-kart or, Baja racer,
Robots.
robots. Yeah. Though they don't get any of it. Doesn't seem like they get much of the measurements beyond like a micrometer, maybe. And that's from my take of what I've seen. But,
Right.
And sensors that are throwaway sensors, right? I know there's a lot of people that I've chatted with that they're like, I didn't realize I had a thermistor in my 3D printer. It's like, well, yeah, sensors are everywhere, but those are, a dime a dozen type thing to them.
There are some really good engineering professors who I connected with, who were part of the group with the ASEE, the American Society for Engineering Education, where they have measurement systems courses as a part of their engineering curriculum. They're usually advanced courses, but a couple of them I gave updated slides to. One of them, Jay Booker had worked with in Wisconsin years ago, and I had followed up with them because I ran into them reviewing papers for ASEE and gave them some updated information probably 5 or 6 years ago. So just before I retired, on traceability and how the definition of traceability had gone from this nationalistic concept to traceable to the SI.
Yep.
Right. So you're not traceable to NBS. You're not traceable to NIST. You're not traceable to SANAM. You're not traceable to BIPM. You're traceable to the SI, the International System of Units. Yep. And one of the other questions that you had asked me about ahead of time here had to do with what were some of the major changes during your career. And that would definitely be one of them, is that, from when I started it, everything by law in Minnesota had to be traceable to NBS. And eventually NBS changed the name to NIST, and then we had to be traceable to NIST. But by the time I was done, we're talking about traceable to the International System of Units, with all of these essential elements being in place, that it's not a NIST number, that it's not a SANAM number, right? That you have to be able to assess the full scope of what's involved with ensuring measurement traceability. And so that would be one of the other key things that has changed over the years.
And do you feel that so what do you feel are the big challenges ahead? Obviously, technician shortage, right? We obviously see that, and we talked before the podcast started that's even in that higher realm of knowledge and understanding, right? We're kind of losing everything.
The big challenges ahead. One of the things that I think is interesting is one of my early tasks at NIST was to create the Advanced Mass Seminar. And so what that course does is it looks at the measurement weighing designs that are used at NIST, uses the NIST mass code for data reduction. And so we instituted that class with support from the Statistical Engineering Division at NIST to talk about how the designs are solved and how the uncertainties are created using those weighing designs. So we created that in 1993. And when I started at NIST in 1990, only about half the laboratories even had computers. So when you think about the history, I was one of the early adopters in Minnesota to even have a computer in the lab. We were using this bulletin board to log on and download information and share with other labs at the time. So it was before the internet. It was before email. There were faxes being used, and a lot of faxes being used back in the 80s, right? But half the labs labs didn't have computers, and if they did, maybe they weren't adequate. So I had to share information with the labs on here's what kind of computer you need to buy. And at the time it was something like, oh, you need to have a 286 processor with a math coprocessor. And now you can use any kind of computer that's on the market, really. But at the time, there were people with computers that only ran on floppy drives, right?
Oh yeah.
And they were the big 5-inch ones, right?
Yeah.
Oh,
right.
you're not going back to the 10.5 or whatever.
Yeah, not
NIST,
me.
Play by
NIST
Oregon Trail.
the NIST Force Lab, they have one of those in there. I think it was it an 8.5 or 10.5. I said, is that where all NIST secrets are kept? And they just laughed at me.
So if you think about the changes we've gone through with computers, right? And so now what I see as the latest thing that they're trying to push through is digital calibration certificates.
Mhm.
And standardizing on digital calibration certificates. And after spending years and years and years of trying to get people to get their regular certificates right,
Yep.
I think about
It's an
digital
art.
ones. And I'm like, you can't get the paper ones right. How are you going to get these digital ones right so that they're consistent and uniform? And wouldn't that be great if they could? Yeah.
Oh yeah.
But
I
how
think
do
they
you
can.
how do you read them? And how do
Blockchain.
how do you read them?
I think blockchain. I think I
Yeah,
don't.
okay.
I do not think we're there yet.
No.
And I think
No.
in the standardization, I think that there's, I know what PTB and the Germans are, Europe's leading some of the way. And then hopefully we will get harmony, the famous last word, right?
Yeah, right.
Hopefully harmony and agreement that we can all agree on one standard and not have 5 or 6 out there that are going to just create chaos. And from what I know, I'm not a big, so the audience is, I am not a Bitcoin fan. I am not a cryptocurrency fan, though I respect some of what's going on with blockchain, and I could see it applied to calibration certificate, to calibrations, where it would be really interesting to be able to pull all the history of that device in what you could do with some of the blockchain. I know they're using it for freight forwarding and this, and it eliminates a lot of paperwork. I think we're far off from there, Georgia and Ryan, though. I could see a world where you could scan something and say, this has had 20 years of cal, 2 fails, 18 passes, and that you could really dive into it and garner like a lot of cool knowledge from it.
So that I think is one of the things where we're going, where I agree we're not there yet. And I look at the whole process of how standardization happens or how it's supposed to happen. And I used to joke about this in seminars, because after being on ASTM committees or NCSLI committees, or even just teams of people, what happens with standardization, really, when you're looking at consensus, we argue about it and argue about it and argue about it till we get tired, and then we give in and say, okay, let's go.
Yep. It's been 2 years. Why are we still arguing about this? We had one where we were going to make our own definitions, and I said, this is not wise. The VIM is already in existence.
Right.
And so 2 years of negatives of everybody says this does not align with the VIM. It was, oh, we'll just align with the VIM. And, hindsight is everybody should have just 2 years ago known enough to say, look, we're going to get all these negatives. Let's align with the VIM. That did not happen. It was painful. It was a really painful 2-year experience to go through all the negatives and the ballots and everything were the obvious answers. We should not be creating new definitions.
Is this one of those things where it's someone pushing a maybe veiled personal agenda?
Not on this one. Sometimes they do. This one was more that I think the group, certain people just had it in their head that this is the way we need to press forward type of thing. So the opinions, right? The committee, the joke I say, and I might have said it on here if I haven't, is you ask a committee to design a racehorse and the end result is a camel. And that's typically what
exactly
can happen. And it's, unless everybody has agreed upon rules and they all don't they all do not conduct themselves. Been in a lot of different groups, and some groups that I've been in, they have rules: no cell phones. This is what we're going to do. This is how we're going to have meetings. This is if someone disagrees, we're going to do. And they have all these rules, and I think they function a lot better than just the open forum. Everybody's voice is heard. But anyway, that's beyond this. Let's get back to Georgia, the NIST Mass class. This one's an interesting one because you have one, and I'm going to get it wrong, and I hope you can correct. At the end of all this statistical analysis, and I like I said, I'm probably going to get this wrong because I'm going off of memory. The student has 2 weeks. They take home work each night, really learning. They're making measurements, doing anything, and at the end they weigh what? That's where I want to say that I was going to get it wrong because it's something common, right? Where they have to weigh something and do a full budget.
Okay. So in the fundamentals of metrology class, that's 1 week long, and they're weighing pennies.
Okay, I'm intermixing them. I'm intermixing the 2 week with the 1 week. But at the end of the 1 week one, they're weighing pennies.
Well, they're not just weighing the pennies. So they're doing dimensional measurements on the diameter, dimensional measurements on the thickness. They're using weighing the pennies. But as we start out in that class, we talk about what are all the possible things we could measure on a penny. So we could drop it on the floor and measure the frequency. We could taste it. I don't encourage that because they're disgusting. We could look at the chemical composition through destructive testing. So we have them create a whole list of all the things that could be measured. And then when it comes time to talking about the uncertainty analysis of that, the temperature is not something that we actually measure when we're looking at the temperature of the penny, but the temperature definitely affects the buoyancy when we're weighing it. The temperature definitely affects the diameter or the thickness. So it contributes to the uncertainty of that measurement. So we have to say, okay, well, we didn't measure temperature, but how do we quantify some measure of uncertainty for the dimensional measurements or the weight measurements based on temperature? And so we go through that whole process. So while they are only creating that certificate that has weight and diameter and thickness and volume, which is calculated, that they put that together on the certificate, and the certificate has to be right with all their units and symbols, of course. But they're having had discussions about everything. And so what we talk about as a part of that course is that, we're not going to add pennies to our scope of measurement for accreditation, right? But what if you wanted to add something new that's not currently on your scope? What is the process you would have to go through? And so we talk about the pennies from start to finish to say, okay, the first thing we're going to have to do is research. What do we know about pennies? What do we know about what the specifications are for pennies? What does the mint tell us about pennies? What does Canada's mint tell us about if we've got Canadian pennies? How do we come up with and validate a procedure for making the measurements that we're going to measure? So we go through from start to finish and say, okay, what if we wanted to add thermometry to our scope, and we don't have thermometry on our scope yet? What's the first thing we're going to do is say, okay, what range of measurements might we want to have? What equipment and standards do we need to have? Are we going to focus on liquid and glass? Are we going to focus on thermistors? Are we going to focus on thermocouples? Are we going to focus on a narrow range of, 0 degrees Celsius to 100 degrees Celsius? Or are we going to go to 1200 degrees Celsius? And then what kind of equipment do we need to have? So we go through this whole research process. Then, okay, so we've got our standards and our equipment in place. Now, how are we going to do that? Don't we need to have some validated procedures? And so the same process that we did with the pennies can apply to any new measurement that we wanted to add to our scope for the laboratory.
Love it.
And so we try to make that parallel so they get the concepts down, that it's not about weighing pennies. It's not about adding pennies to our scope. It's the measurement concepts that we're trying to put into place.
This is very
that's so yeah.
this is very timely. I was going to say this question just came up on that Facebook group this week, Henry. Who writes the lab scope? And then Mike Lynn chimed in. It sounds like you do. So yeah, how does a scope appear out of, does it just get birthed somewhere? No, it actually has to go through a process to be created.
No, and it's fantastic because it's just relatable, right?
Mm-hmm.
Everybody knows what a penny is. You can envision, and to Georgia, you can feel a penny, you can look at a penny. It is something that is truly relatable. And at the end, yeah, it's like you said, it's not about weighing, but you can visualize all of that. And just as you were walking us through, I was listening and taking some notes. And as you were walking us through it, I was hearing, thinking about all this and the process that goes into it. Then I started thinking about, the uncertainty budgets where everybody, gets lost in all of this. And then the equipment that's needed to make the measurements, and how do you source the equipment, right? Do you just trust the manufacturer, or do you call around? Do you do these other things? I mean, I know you've seen that in your where you've been, but how the weights and measures are operating on a lot of different ratios, right? For lack of a better terminology, with OIML, is it correct on this?
So historically, what the standards with OIML is the International Organization for Legal Metrology, and they publish a number of recommendations. So, for example, in Mass, it's R111 is the recommendation for that. And what that documentary standard says is that the uncertainty must be less than 1/3 of the tolerance. Now, the question comes up, you have to know the uncertainty to prove that. So it's not really working on ratios. You still have to have the uncertainty in place to prove it. And so even I see this with the TURs and the TARs, or whatever you want to call it. If you're going to say that our uncertainty has to be less than 1/4 of the tolerance, or 1/4 of the requirement for the next level up, prove it. That's the thing about metrology, is that show me the data, right? And so you have to have that uncertainty calculated. You have to be able to demonstrate that uncertainty to say that, in fact, it does meet that requirement. So the tolerances are there, just like they are with some other measurement areas like gauge blocks, for example. How do you put a gauge block in a different classification? Mm-hmm. They have different tolerances, but you still have to prove that your measurement capability is sufficiently small to meet those requirements. And so, it's there. The ratios are there, but in a sense, you still have to prove it.
That was a very leading question, self-serving.
Oh, okay. All right. use it however you need to, right?
No, but yeah, that is a problem. Ryan and I have talked about that numerous times, so it didn't need to. I just wanted to bring it up a little bit since we were having you on from this and training everyone. But people do get stuck on these ratios, and it's pretty dominant in our field right now.
Because it's lazy. It's say trust me is basically what it does, and say, oh yeah, it meets this. But you can't just trust all of that is true. When I look at the equipment resolution, for example, if the equipment resolution is 0.1 and somebody says that the ratio must be 0.01, you better have data to support that you can actually meet that. And
my repeatability studies, George, my standard deviation is going to be 0 on this.
Yeah, that's pretty amazing. Yeah, exactly. Yeah, if your standard deviation is 0, you take the resolution, divide it by the square root of 3 or something like that to have your, smallest uncertainty is a rectangular distribution from your resolution. Mm-hmm. If the standard deviation is 0.
Yep. And then you can get into it. Yep.
Yeah, we put things in place to keep people from saying, "Oh, our uncertainty is 0." Yeah, that's pretty impressive.
Do you, over your years, I know you guys are very aware of the possible bad actors out there in third-party cal. I'm sure at NIST, you guys are well aware of that stuff. Does it ever bother you that there's just those labs going out there and doing the lick 'em and stick 'em, the sticker pusher type stuff? is there any way that we can eliminate that out there, or is it just kind of one of those things that people have to deal with and do the research? I guess it's kind of like other services out there, and you kind of have to look out.
So back when I was in Minnesota, one of the companies that we did calibration for gave me a mocked up certificate that was cut and taped together with different letterhead than the company that did the work. And I recognized the signature for the person who actually did the work. It was not the company who was on the letterhead. And so I said, who regulates this? Nobody regulates that, right? And I had another instance where a director of a laboratory called me and said, I have my metrologist on the phone with me, and we want to admit to you that all of our control charts that we submitted for review were fabricated.
Oh, great.
I had another instance where a supervisor called me and said that their metrologist had passed away, and they opened up their desk after they were gone and found the master copy of the calibration certificate that they used for every other certificate for every other weight set that came into the laboratory. She went and started looking at all of the measurement data for all the other certificates, and they were all identical. So this person was not doing any measurements at all. They were pulling out their sample certificate and marking it up. Now, in a couple of cases, people lost their jobs, right?
Mm-hmm.
One of the talks that I gave at Measurement Science Conference was in a session with Mark Rufinacht, and Mark was talking about something in data integrity, and I was talking about data integrity. And this idea about how many people had been arrested and gone to jail in the forensics community for falsifying data. And so it happens. And there's nobody who regulates that other than maybe the police or an attorney general or somebody who's looking at fraud cases,
Mm-hmm.
or maybe there's a major law case that gets brought up. But in the world of metrology, there's very little that happens other than I have seen A2LA pull their accreditation from a lab because they were falsifying data. And so you might find it that way, and maybe they don't get accredited, right?
Mm-hmm.
Or the other thing that I have seen is there was a company that was accredited theoretically, and I joke about having my Georgia's accreditation service in our mobile RV here. And so I did not sign the mutual recognition agreement with the International Laboratory Accreditation Cooperation. So I am not a signer of the ILAC MRA. And so my Georgia's accreditation service, I can go out and just go and accredit any laboratory I want and give them a certificate for their wall, and I can assess them however I want. I don't have to be I don't have to have a stinking signature, right? And so we joked about that, but when we were doing assessments of calibration certificates that people brought to NCSLI and MSc workshops, one of the certificates that we found had an accreditation logo on it. And when we looked up that accreditation body, they were not a signatory for the ILAC MRA.
Mm-hmm.
And then I had a call from the FAA. So the Federal Aviation Administration was investigating a laboratory in Brazil. The laboratory was doing torque for airplane maintenance, and they were accredited. But their accreditation body was not the Brazilian accreditation service. So they they didn't have all the pieces in place for that. And so is that direct fraud? Did they intentionally mislead somebody? Is there something with data integrity that means you go the extra mile to make sure all those pieces are in place? Is it intentional? Is it unintentional? You have to prove motive in some of those cases to say that it's legitimately fraud.
Gotcha.
But NIST doesn't regulate traceability, and NIST doesn't regulate that. So when I was involved back in Minnesota in the 80s with that certificate that was falsified, there's nobody in place who was going to police that.
Yeah.
You just hope word gets around.
Right.
Mm-hmm.
But you really have to pay attention to all of those details and investigate that yourself. Mm-hmm. So the whole thing with supplier evaluation in 17025 really reinforces that. And so if people are fully following the supplier evaluations and making sure all the pieces are in place for traceability, and that all the criteria are there, I think we can police some of that ourselves.
Sure.
Are they though, Georgia? I would ask, because what we typically see is just a questionnaire that's emailed. It's a self-honest audit most of the time. If we're the supplier, someone says, "Oh, here, I need you to fill this out," and someone had these things, and a lot of it doesn't matter. We just went through a new pick audit and things I shouldn't say online and do. One of the dings we got is because we weren't following up with making sure that there wasn't the on-site audit, right? They have a rule that says, hey, you cannot have virtual audits. You have to have an on-site, and it should not lapse by more than 48 months. So on our end, we're dealing with I'll say the names. We're dealing with Keysight, Fluke, NIST, of course, but NIST doesn't fall under this, and State Lab and everyone else, and some of the ABs. And what came out of it is our procedure became better because it was a miss. And even though I'm a little bit jaded on that, is that really important for the risk level with these companies or not? I think that's a deeper dive into what else are you missing if you're missing that or overlooking that. So, but my question is, all I tend to see that comes into us are just fill out these papers that have these 12 questions or 20 questions, or sometimes they have a ridiculous 100 questions where they want to know the square footage of your facility. And what does that have to do with our ability to perform a calibration for the one force gauge that you send in a year our square footage of our facility, it comes into play? But
so there's different things with supplier evaluation that I would look at, right? So if I was looking at supplier evaluation now, and I'll pick on you since you brought it up yourself.
Yeah, go ahead.
So if I was going to assess Morehouse, so I could go by word of mouth and have that as a part of my supplier evaluation process, right? I could evaluate your calibration certificates and make sure that you're representing your units and symbols right, so that I have some confidence in those certificates. And I would look and say, okay, who is your accreditation with? And are you accredited? And is that accreditation on your scope? Now, I know with new pick, they have some different requirements, and so does the FDA with the Food and Drug Administration. So in the nuclear industry, I'm kind of glad that they have some additional pieces in place, because I have evaluated stuff for a nuclear industry in the past that was not in a good shape. But when I look at that supplier evaluation, I would give preference to your accreditation. Who is your accreditation with? Is it current? Are these measurements on your scope? Does your certificate look right? I would do that level of assessment. Do I need to be on site at your assessment? I would say no. I would say you had an assessor come there from, I think it's A2LA, right?
A2LA, well, we're a little unique because we're doing A2LA and NavLab, because the NavLab has the technical, and we found, there's no offense to any assessor, though we found that having that technical and that extra assessment just makes us better, because one's going to miss. Look, assessment's just a snapshot sometimes a 2 or 3 day snapshot.
So I would look at that and doing an evaluation of you. And so I would ask those questions, maybe on a questionnaire. Do I need to come to your site to evaluate it, to have confidence in that after looking at the history and the word of mouth and the assessments that you've had done? I don't think I need to come on site, right?
And they watch the podcast and they would know that you're like legit.
But if you say, came and assessed Georgia's accreditation service, and oh, by the way, I can check torque in my motorhome also, or I can check. I've got these force gauges in here. We can go back here. You want to have some confidence in me? I accredited myself.
Right.
I think you'd want to do a site visit, right? That's resonating. We would hire you absolutely to come check out, because I know you so well, and I know we would be better from having that experience, because you are very attention to detail, and I'm sure you would find something that we're missing. And that's what some of this is about, right? It's a continuous improvement journey. And one of my favorite authors, Simon Sinek, says, what's the purpose of being in business? And everybody make money, do this. And the simple answer is just to be able to stay in business. Right. And to do that, you have to continually improve and evolve. And, our measurements tomorrow are likely going to be much better than today, because we'll have learned some other facet of how material works, or aging, or the knowledge of just repetition and doing things. You can kind of get in your head that, oh yeah, this indicator here that we were having issues with 10 years ago, if we do this, now we just learned the other day, George, it's just craziest thing. Updating firmware on one of the indicators, we were bricking them, and of course it takes, you brick the second one. The first one's like, I did something wrong. The second one, something else is wrong. Mm-hmm. And we learned that you have to hold the power button as you're flashing the firmware, or it bricks. Now, not in the manual, though. Right. Learned it. The good news is the ones that we bricked are fully recoverable, because it says, oh, yeah, you just hold in the power button and do it. So we didn't ruin anything. So it's not really a brick.
It's a brick if you don't know to hold it. Yeah, it's not really a brick. It's bricked until you learn how to unbrick it, I guess. Right. Not a brick in the sense. So, but yeah, we're always learning, and there's things out there. And yeah, that NUPIC audit, though, it was painful in some regard on that. Like, now it's more work to verify that they haven't gone 48 months without an on-site audit, though. The people we're dealing with, the assumption is with the Flukes, your Agilent, they're going to have audits. But you can get trapped in that. You absolutely, I'm as guilty as can be right here, because I made the word assume, make an ass out of me, assuming that they're having on-site audits. Until you ask, it is a blind spot until you ask. Right. So that's the point.
I'd like to bring back what you're talking about with lifelong learning to the question earlier, in terms of what skills do new people need to have to.
I'm so glad. Yeah, because I hate to do it, Henry and Georgia, but we're getting close to the end. I was just going to transition into that, Georgia. That's perfect. So anyone starting out, because we've got a lot of students, what your advice? Yes, that's perfect.
So this idea of lifelong learning is that just because you learn it today and you get a certificate that you hang on your wall, we must constantly be learning and growing in the field of metrology, because things do change. And so it's a skill, it's a core value that you need to maintain, this idea of lifelong learning. And so I think that that's one of the things that served me well over the years, is that I was never satisfied with, okay, I learned everything I need to know. Now let me go and teach it. This idea that you're constantly learning. So when I was in the Utah lab last week, I saw, oh, hey, there's a new sensor. I haven't seen those before. Let me take a picture of it. Oh, I would like to get one of those because I think they're really cute. I'm not going to name names and do, what kind of sensor it was, but it's a learning opportunity even now, that you don't stop learning. And so I think that that's a key thing. So, technology is going to change, but we really all just need to keep learning, and that needs to be our core value.
and
Thank you.
brush up
Yeah.
on it. Like the control charts, you've taught it for years, and maybe people have had all through Six Sigma, or they've had statistics, and then it goes on, and then they forget why they're doing what they're doing, or they forget this or that, or there's somebody else created something, so they just keep on with it, and then I could talk for hours about control charts, and that's Walter Schuhart. Dillip, our good friend Dillip, that's his hero, and there's a lot of information out there on when. So I'll ask you this: I do have a couple questions as we're wrapping down. How to establish a good control chart? Do you have I guess it would be a bias number, but not really. Do you have a number of how many measurements, plotted measurement points or averages, like how many series do you need if you're just starting out and want to start controlling your process? How many do you need to start gaining value from that? I'm saying this wrong, Georgia. Not gaining value, because you gain value the time you make your first and second measurement. How many do you need to start establishing a more robust confidence level in that measurement?
So I can give you a quick and dirty answer, and tell you that you can look at one of the good measurement practices that we published at NIST. and find out that answer to that question. But to answer your question, so I'll tell you how to fish, and I'll tell you here's the fish, right?
Awesome.
So go look at the procedure, and it will tell you this information. But you'll gather some data, and if you look at the T statistics, you'll know how many measurements you need, really.
Sure.
Right?
Sure.
Okay. So if I can start a control chart with 3 measurements, but what we say is that you don't have a good set of limits until you have 7 to 12 measurements. The NIST statisticians will tell you that until you have 25 to 30 measurements on that control chart, you do not have valid repeatability data that will go into your uncertainty analysis. So 7 to 12 to get started, 25 to 30 to have valid uncertainties. That would be my pat answer.
That's
now in reality, it depends, right? And so that's a quick and dirty answer.
No black and whites in metrology, right? No hard cut.
Yeah,
that goes with, there's a video series, and it goes with the minimum was 7 on that. And I thought, and I get it, the T statistics 24, and then you start getting diminishing returns through 30 and more.
Right, exactly.
Yeah. So we get it. But 7, and some people say 10, and some people will say 3, and it's, if you're doing a temperature bath, sometimes it takes a long time there, Ryan, the temperature bath. Sometimes it takes a long time to make those measurements. So it's a trade-off.
Oh, yeah.
What's your risk level?
So I'll give you an example of one of the measurements I talked about last week. And also when I was in the Idaho laboratory, they have 50 or 100 gallon approvers in the lab. They have 500 gallon and 1,000 gallons that come in for calibration. How long do you think it takes to fill up a 1,000 gallon prover with a garden hose?
Longer than a couple minutes?
Yeah, longer than a couple minutes. So you have to do a wet down, and then you have to do run 1 and run 2 as part of the procedure. Okay, so you have to do a wet down so the valves are all wet, so that the water retention after the valve is consistent, so that you're not maintaining part of the liquid in the plumbing, if you will. And so then you do 2 runs, and if you have to do an adjustment of the gauge, you have to do another run. So it will take a day, at least one full day, to do 1,000 gallons. Well, how many runs do you need to get a control chart? And what's going to happen to your workload in the meantime while you're trying to get a control chart set up for 1,000 gallons, right? No other work is going to get done. So it takes a long time to get some of those charts in place that are valid. Yep.
And you're probably going to steer towards the 7s enough in that scenario, and let's just keep grabbing them as.
Yeah, not if you want it on your scope, because you don't have valid uncertainties.
Catches you there.
Well, there's some organizations that claim like you have to be making measurements for a long time before you get accreditation because of this, because you need to get all this data into place. Right. Instead of just, I started up 2 weeks ago. I mean, there was one, and we do have to, and there was one that I forget. It was Chris Parrish of Oxbridge was saying, hey, this software is so great, you can become ISO 9000. I think it was, ISO 9000 accredited in less than 2 weeks was what they were pushing, because this software was so great. That's all you needed was this awesome software. And yeah, it's as simple as that, right?
That's all you need.
As we wrap up, so the people, the a little more about Georgia. Georgia was, as the group, the listeners know, co-author of the Metrology Handbook. You mentioned Jay Booker. I think Georgia's you were on version 1, 2, and 3.
I
2 and 3.
I helped do reviews on 1 and 2. I was only active as an author editor on version 3.
Right. So, most recently we were in Cleveland. I believe, it was Cleveland, won the Wild Hack Award at NCSLI. That's their highest honor. 2015 education and training. You had 2 bronzes at NIST, and did you have the MSC? What did you?
The Andrew J. Whittington Award.
Yeah, you had the Whittington Award as well. Yep. So these are some of metrology's highest honors. Am I missing anything, Georgia? I'm sure I'm missing a lot.
That's more than
Metrology royalty.
Yeah, well, I really wanted to say the level of respect for Georgia. I have a tremendous amount of respect for you, Georgia. I'm so privileged to know you and to have had classes and to get to be part of your retirement when you were kind enough to invite me down to present on load cells and everything else. Though what I saw down there, for the people listening, everybody there, I think would say really, really tough. That to describe you as how like tough to though, just everybody says Georgia makes you better. And I think that is the hallmark of this. Yeah, it is, because people like think, oh, I want the easy pass. You're not getting the easy pass.
Not from
right?
me.
No way. And that's why the confidence in measurements, we talk about likelihood and risk, the confidence in measurements goes way up. Right. So there are not enough people like you out there. And I think Ryan, and I speak for Ryan, can speak. I'm so privileged that you joined us on this podcast, and the listeners can have at least an hour and some time to get to know you. And hopefully they've taken a lot away from it. I know I'm forever grateful. So
yes.
Thank you.
Same here. I said I've been following for years. So you're kind of like getting to interview a celebrity in metrology to me.
I would say so.
So it's Georgia, sort of like Madonna or Prince, right?
That's all you need, Georgia.
All right. Well, thank you guys. Yeah, thank you.
And if anybody, I know you're a little bit away from some of the game, but if people want to reach out to you, is there a way to do that, or should we save it for future podcasts? Hopefully we can have you on again. I'd love to get your thoughts of the future with AI and all that down the road.
Conventional and true mass, which we didn't talk about. I had that on my list.
So many things.
We ran out of time.
Yeah, I've used played with AI some on creating learning objectives. So that would be an interesting conversation. So if people want to reach out, the easiest way right now, since most of my social media is no longer exists, so I got rid of my LinkedIn account. I got rid of a lot of the professional mechanisms. So I am on Facebook and I am on Instagram. If people follow me, they can message me that way. If they happen to have my cell phone number, they could text me.
Good old fashioned way, right?
Yeah.
And it's Georgia Harris. And then also a little bit of plugs. Georgia has written books. If you are an avid hiker, Georgia has some books on Amazon, and Georgia's husband, Randy, is a flutist, and he has some pretty fantastic music that is available for download on Amazon as well. Do you want to plug that quick, Georgia? It's not metrology related.
So you can go to our Win Tucker music channel on YouTube. So the Win Tucker music channel, he has 6 albums out now, and 3 of them have been done in our motorhome. And I do all the photography and video work for his music videos, and he does all the audio on those. And so together, when we're traveling around, we like to do music videos of different places where we're hiking or traveling. And so you'll have some this week from Arches National Park in Utah. And now we're over in Colorado. So we'll probably get Colorado National Monument over the next couple of weeks and put up a new video. But almost all of his earlier albums have music videos associated with them. And so you can watch them for free without having to pay to download on Amazon. But you're welcome to do that anyway. The royalties don't buy us dinner, just so you know.
And your book, the book that you have.
Yeah, there's a couple of books on Amazon that you can get about hiking the Appalachian Trail.
Yeah, very cool.
Awesome. Well, I'll have to check those out. My wife and I are very much outdoorsy, so that's right up our alley. Well, Georgia, thank you once again, and thank you all for listening.